At split face operations. The split face operation splits one face into two or more real or virtual faces. The split operation fails if there are bad geometries or the operation will be aborted. But you can always automatically ask, or you can ask Gambit to automatically heal the geometry or repair the geometry before do a split if only two entities are involved in the split operations. Using this particular default geometry volume boolean method, you can actually control the way the split will be done, or whether you want to do a smooth and heal operation before splitting. If it is equal to 3, it attempts to preserve the existing vertices and the labels. This is typically useful in creating journal files and using journal files, because we want to retain the labels which are there, because most of the commands in Gambit, they are label sensitive. So what the split face needs is, it needs two things. One is it needs the target face, means the face which you want to split, and it needs the split type, it means what type of split that you want, and it needs split tool. These are the three things that it needs. So target face can be, it means the face which you want to split, it can be real or it can be non-real or it can be virtual. If it is real, it creates two real faces. If it is virtual, it creates two virtual faces. The split type, there are different split type depending on what is the split tool that you are using. The first split type is face real. It means you are going to use a split tool, real face as a split tool. That is what you are going to use. What it does is it splits the real target face with the real split tool face. Cannot split the face that is mesh link. It means if you have if you have one face which is linked to another face for meshing, you cannot split that particular face because it will change the topology. So resulted face depends on the split tool face intersecting or overlapping the target face. It means the resulting geometry or resulting faces, that depends on whether the split tool overlaps the target face or split tool intersects completely the target face or not. If it is intersecting, what it does, it creates two or more faces for a complete intersection, and if it creates the dangling edge for incomplete intersection. For example, in this case, this is the split tool, this is the split tool, and this is the target face. So this one is the split tool and this one is the target face, and if you want to split this particular face with this particular face, as you see, the two faces are intersecting each other completely, so definitely two faces are going to be created. So this is nothing but split with fully intersecting split tool. But in this case, this is the target face, this is the target face and this is the tool face. If you see, tool is not completely intersecting the target, so definitely after the split there is only one face which is going to be created, but there will be a dangling edge. We call this as a dangling edge because it is not completely intersecting the face, and definitely this is not good as far as meshing is concerned. Unnecessary, it has a meshing constraint. We can always clean those operations. So this is nothing but intersecting target split tool face. Now if the faces are overlapping, it means if you have one face, for example in this case, let's say this is the target face, and let's say these are the split tools, the small rectangular face and small circular face, let's say these are the split tools. Now they are overlapping to each other. Once you do a split operation, means once you say that split this particular face using these two faces, then what it is going to create is one face is going to be divided into three faces. Again similarly in this case, this is for planar faces. In this case, for non-planar faces, again as they are overlapping, two faces are going to be created. So this is like for target and a split tool face which are overlapping to each other. This is a typical split tool or split face form using a real face split. So let's have a look at that particular form. So again, let me create some geometries for splitting. So face, a rectangular face of size 10, and then let's say again a rectangular face of alpha is 10, but in positive, so this is the case. Now this comes under overlapping phases. So go to split phase. What you want to split? Let's say I want to split this particular phase. The split width is phase real. What you want to split is this, and when I say apply, what I got is I got two phases. Now when you are using split with real phases, there are different options popping up. These are retained, bidirectional, and connected. So let's have a look at what retain does. So whenever I say split this phase with this phase, and if I activate retain, and when I say apply, what it does is whatever the split tool by default, because Gambit by default is going to delete the split tool. So this particular phase is going to be deleted. If you do a split operation, this particular phase is going to be deleted. But if you want to retain this particular phase, then you can activate retain. Retain is nothing but what you want to do with the split tool. Do you want to retain it or do you want to delete it? By default, Gambit is going to delete it. So when you activate retain, it will retain that particular split tool. Bidirectional is nothing but do you want to split split tool also? It means do you want to split the phase which you have used as a split tool. So if you activate bidirectional, what it does is, first is it splits this particular phase, it splits this particular phase using this phase. So this particular phase is going to be splitted using this particular phase, and it also does the reverse thing. It also split this particular phase using this as a split tool. So both the splitting will be done, and as a result there will be three phases. One will be this phase, one will be this phase, another will be this phase, and third will be this phase. So this is nothing but bidirectional split. That is what bidirectional split does. Similarly, when you say connected, connected is something to do with what will be resulting phases. Now when I say split this particular phase, this phase with this phase, and if I deactivate connected, and when I say apply, now these two phases which are resulting, they are not connected to each other. It means they will not share a common edge in between. But when you activate connected, they will share a common edge in between. So that is nothing but these three options. Retain, it retains the split tool. Bidirectional, it also splits the split tool itself using target phase, and connected is the resulting geometries will be connected to each other. That is the meaning of or effect of connecting. So retain is nothing but retains the split tool phase. Bidirectional is nothing but splits the tool and target phases with each other during the split operation. Connected nothing but connects the spaces that results from the split operation along their common edge. So this is most of the time we will go for connected operation because we want to have connected geometry. The another split tool that you can have is phase virtual. It means if you have any virtual phase, you can use as a split tool, and that is same as the real phase operation, but in this case there is no connected, because by default the things are connected to each other. By default the splitted phases will be connected to each other. So phase virtual split operation, what you can do is you can use virtual phase as a split tool. So if you go here virtual phase, you can use any virtual phase as a split tool. So retain and bidirectional, they are same as your real phase operation. You can also use virtual edge as a split operation. This is also a very useful tool for decomposing the geometries. Virtual edge, what it does is it uses that edge as a split tool, and it divides the face into two phases. For example, in this case, if you see in this case, I'll delete one face. Let's say I'll delete this face, and let me create one particular vertex on edge. And now let me create virtual edge without any host between these two vertices. So I have one virtual edge, so I can use that edge for a split operation. So I'll go to face, split face, edge virtual. I want to split this particular face using this particular edge. Apply. So if you see, I got two faces. This is one face and this is another face. So what it does is the resulting geometries definitely they will be virtual. This tolerance is nothing but if there is a gap between this edge and a face, then you can actually control that through this particular tolerance value. So splits a real or non-real target faces using set of one or more real or non-real edges. Always creates a virtual face. Can consist of single edge or chain of connected edge, in the sense like right now I had only a single edge intersecting the complete face, but I can always have a chain of edges connected to each other, and the first vertex of that chain is on the boundary and the second last vertex is also on the boundary. So I can always use the chain for split operation. For example, in this case, let me split this particular edge into number of edges. I will say virtual connected at point. So this. Now if you see this particular split tool which I am going to use, that is not made up of only a single edge, that is a chain of edges. So I will say split face. I want to split this particular face with these edges. You can say apply. So if you see, what I got is I got two faces. So the constraint here is the first vertex of that edge chain and the last vertex of the edge chain has to be on the boundary of the faces. That is the constraint from Gambit side. if you want to use virtual edge as the split tool, the outermost end points of the vertices of the split edge must be connected to the boundary of the target face. Yes, tolerance is nothing but maximum allowable distance between the edges in the split tool edge set and the surface of this. So that is nothing but target. So this is, you can control the tolerance. So this is split face using a virtual edge. You can also split a face using virtual vertices. If you have vertices, set of vertices on the face, you can use that as a split tool. So vertices virtual split operation splits one or more real or non-real splits with one or more real and non-real vertices. Virtual face will be created. The vertices must be located on the surface. If the first and last vertex are on the boundary, if the first vertex and the last vertex, if they are on the boundary, it will do a complete split. If they are not on the boundary, if they are in between, if the first vertex is somewhere here and if the last vertex is somewhere here, the dangling edge will be created. So no complete split will be done. So you have to avoid for creating self intersecting edges. It means if you are given some vertices, then it should not happen that you are creating a self intersecting edge. So in that case, Gambit split operation will not work. So this is nothing but split with vertices, virtual vertices. Now when you are given a vertices, you can actually control the tolerance is nothing but distance. So if you go to split face and if you go here and say vertices, you can actually give the vertices on a face, and let me create vertices on a face. So go to create vertex on a face. I want real or virtual, that doesn't matter. Let's say I will create some vertices on this particular face. So I got vertices. Now I can use these vertices as a split tool. So I'll say split face with vertices. Which face you want to split? For example, I want to split this face using this set of vertices. If you see, what is done is it has created one edge which is passing through this particular vertices, and then it has used that edge as a split tool. That is what this virtual vertices does. Now this tolerance which is there in the particular form, if you see, there is something called as tolerance. This tolerance that is nothing but maximum allowable distance between the split tool vertices and the surface of the target face. The shaped edge option which is there, that is nothing but two vertices on the boundary connected by a straight line if above option is not active. If you activate this option, then what it does is connect the vertices such that the edge resulting from the split operation bisects the interior angle of the face boundary and its endpoints. It means, let's see whether this operation works or not. This particular face and these two vertices, this is the face without a shaped edge. Now again same face and these two vertices, and now activate shaped. So same thing happens. So what it does is, what it's supposed to do is, it's supposed to create the edge in such a way that it is going to bisect this particular angle. If you see this particular angle and this particular angle, that is what is it's supposed to do. So that is what shaped edge will do. You can always split the face using locations. Again, that is a virtual split. A split tool consists of two or more points or locations. Only virtual face will be created. First and last point specified must be on the boundary of the face. Creation of self-intersecting edges must be avoided. So you can provide the face or locations on the face. So again I will say location on a face. It will ask you, okay, this face, and it will ask you the locations. The first location is on the boundary, second location is somewhere here, the third location is somewhere here, and fourth location is on the boundary, and I will say apply. If you see, it has splitted that particular face into two faces. Now again there are two options called as merged resulting edges and shaped edge. What merged resulting edges does is, like, you imagine that there will be one edge between 2 points. So I'll just deactivate merge resulting edge, and now let's see what is the effect of this. If you see 2 points, there is one edge created in between. So this is one edge, this is one edge. So if you have a look at this, this is one edge, this is another edge, and this is the third edge. Now when you say merge resulting edges, when you activate this particular option, what it does is, it creates these edges and then it merges these edges and then it uses as the split tool. So for example, if I activate merge edges, and again this face, this particular location, this particular location, this location, and this location, I will say merge resulting edges. So if I say it has merged resulting edges, so this is nothing but virtual location. Many times these options are useful to decompose the geometry into some particular decompose geometry in some particular way, so that we can create all hex mesh by Cooper or map, something like that. So this split location will ask you UV values, it will ask you UV values, and merge resulting edges and shaped edges will be, that is same as that we have seen in other operations. This is nothing but split face. Now another operation is there which is nothing but merge particular face. Merge face merges two faces into one face. The next operation that you can do on faces is merge faces. This operation merges two or more real or non-real faces into single real or virtual faces. What it needs the faces to be merged, but the constraint is they must be connected to each other. It means they must have a common edge in between. It also needs what is the merge type and merge edge option. I mean, do you want to merge edges after face merge or not? Merge types are real and virtual forced. It does real merge if all the faces are real and with the similar underlying definition. Virtual face if the real is failed. It does not allow to merge the faces whose angle between normal is less than 90 degree or greater than 270 degree. It means if the angle, included angle in between, is very low, then definitely it will create a very bad geometries for meshing, like a very like a surface in which there is a sharp turn. So this will not by default gambit will not allow you to create such kind of geometries. So if the angle between the normals, it means face normals, if the angle between them is less than 90 degree or greater than 270 degree, gambit will not allow you to do the merge operation, but you can always override this constraint by changing this default geometry, face, shape, angle merge default variable to 1. You can always override that particular constraint. So the first merge type is real and virtual force. The second merge type is virtual with tolerance. What it does is attempts to create a virtual face if all the faces in the set meet specified minimum angle requirement. It means if the angle that you have provided, if the minimum angle if the internal angle between the pair of neighboring faces, if the internal angle is less than the minimum angle that you have provided, it will not do the merge operation. If the angle between two faces is more than the minimum angle, it will do the merge operation. So this is again one more option available in merge face. Like once you have merged these two faces, for example, if you merge this face and this face, if you merge these two faces, this is face 1 and this is face 2, and if you deactivate this merge edge option, there will be two edges here, but there is no point in keeping this vertex because unnecessary there are constraints. But when you say merge edges also, what it does is it also merges these edges and it creates a single edge. So this is nothing but merge edge option. This is the typical form for merge face. So let's have a look at the operations. If you go to merge face, and right now I have virtual merge, so I will select these two faces, face 1 and face 2, and I will say apply. These are merged. So I have merged these two faces into one virtual face. So I will select this face and this face. Right now merge edges is active. I will say apply. If you see, it has also merged the edges, but if I deactivate merge edges, I will select this face and this face, it will not merge these edges which are there. Fine. So this is nothing but merge virtual, real or virtual. It will try to merge real, if not possible it will try to merge with a virtual operation. Now if you activate virtual tolerance, you can give the minimum angle. This minimum angle is nothing but the angle, if the angle between two faces is less than the angle which you have provided, it will not do a merge, else it will do a merge operation. So this is about merge faces. Let's have a look at another operation in Gambit. The next operation available on faces in Gambit is collapse faces. Again, that is a virtual operation. This is just to simplify the geometry. What it does is it collapses real or non-real faces between two or more neighboring real or non-real faces. It does the following: splits the space into two or more faces approximately of equal size and merge the resulting faces with their specified neighbors. The neighboring faces must be connected to the face. For example, if I have this face, for example, if I have this particular face, face dot 2, and if you say that I want to collapse this particular face into this face and into this face, first thing it does is it divides this face into two parts. One part is going to merge into this particular face and another part it is going to merge into this particular face in this way. So this is the collapse operation. For example, if you have face 1, for example, if you want to collapse this face 1 into this face and this face, what it does is it splits this face into two faces, then it merges this into this and the remaining part into this face. So this is the collapse face operation, and that is again useful at the time of simplifying the geometry. So similarly, this is one again collapse operation. This is face 1. Face dot 4 is the face which you want to collapse into face 3, 2 and 1. So if you do that, some part of it will be merged into this face and this face and this face. Similarly, there is operation of simplifying the face. What it does is, if there is a dangling edge which is created, maybe because of the split operation and all, it will simplify the face. It will remove this dangling edge. It removes the dangling edges from the faces. So let's have a look at that operation. So as I said, this is nothing but merge faces, collapse faces. So which face you want to collapse into which faces. Now simplify face is nothing but if there is a dangling edge, it will remove that dangling edge. That is nothing but simplify face operation. So dangling edges are the edges included in the list of the edges for the face, but do not constitute the necessary part or the boundaries of particular face. So it will remove the dangling edge. Smooth and heal real faces, that is again one important operation. Smooth and heal, what it does is, whenever there is bad geometry, it will try to repair the geometry. So this repair geometry and topology problems that sometimes occurs in the set of real faces. That is what this smooth heal real faces operation does. Smooth faces, it smooths the face operation is same as smooth edge operation. What it does is it try to smooth the geometry. If there is some bump or something, by changing its definition, it will try to smooth the geometry. Heal geometry option attempts to detect and repair the geometry and topology problems that involve the specified face entity. So there are three steps which Gambit does. One is simplify the geometry. What it does, it converts the spline geometry to analytical geometry. It does the stitch face operation, stitch faces together to form one or more volumes. And repair geometry, it changes the definition of the edges and the faces of the geometry so that model fits together. So we are going to have a look at these operations in more detail in the CAD import and repair you can say lecture. So this is the form for smooth and real faces. This is nothing but one more operation, that if you have a non-real faces, sometimes some operations are not available on non-real or virtual faces. So what you can do is you can convert those two into the real faces. So there are different operations that Gambit does. The technique it is going to be used, it depends on is there any underlying host entity for this virtual face, or is the model is deploys the deformable modeling, you can say, technique, and net surface based technique. So you will see which will be useful by Gambit. The technique which is used by Gambit, that is internal and that is not user defined, it will do a set of attempts, and at the end if the result is if you cannot convert it to non real faces, then it will fail, but it will do all the attempts. So which are the attempts? The first attempt it is going to do is depending on underlying host entity. Let's say you have non-real face or virtual face. If there is underlying host entity, the real face will be same as the underlying host entity. That is what this underlying host entity does. If the face to be converted possesses the single real face as a host entity. So if there is a host entity, then that host entity will pop up in the foreground after converting this non-real into real. The second attempt it is going to do is the deformable modeling. What it does is, first it creates the point information from the faces. If the face is meshed or if the facets are created, then it can extract the point information. If they are not meshed, it generates the mesh or the facets, and using that point information it try to create the real geometry out of it. The third attempt it is going to, both these attempts are failing, the third attempt it is going to do is net surfacing. Again this particular attempt is used, it will extract the point information using the map mesh on the face. If the if the mesh is not present, it will try to generate the mesh, and if map mesh is created, it can have U and V edges, and using those U and V edges it will create the face. So these are the attempts which it will do to convert non-real into real faces. So this is the general sequence of attempts. Example, virtual face that does not have single real host, neither mesh nor faceted. First is attempts to generate a triangular mesh. If failed, it attempts to generate the conformal facets. If failed, it attempts to generate the map mesh. So first is nothing but triangular mesh. Once the triangular mesh is created, it will extract the point information, and then it will have a face by using the deformable modeling. If again that triangular mesh is failing, then it will create the faceted information, and again the faceted information is converted into point information, and then using point information the face is created. then you again, if that is failing, then it will create a map mesh, and then using UV direction, you can say edges, it will create a face. You can always control the number of sampling points that it is going to create by using this particular default geometry face number of sampling points. It is used to limit the number of points used by deformable modeling. The geometry face conformal facet needs to set to 1 to attempt to generate conformal facet. So you can always play with this particular default for this operation. So this is nothing but convert face into non-real into real form. These are the other operations that you can do on a face. Summarize face. It will give the summary of the face, like to how many volumes they are connected, what is the area of the face and all. This is the check that you can do, topological check. It will check the lower topology edges are separate in the loops, lower topological edges are visible and all. It will do a geometry check also, like if the geometries are proper or not. So if anything is failing, then you have to see why that is failing and you have to repair that particular geometry. Then you can allow this is nothing but a query operation, where you can see what is the label of particular face, and total is nothing but it will total geometrical entities, and delete is nothing but it will delete the faces. So these are other operations that are available in Gambit. So this is nothing but smooth heel faces, and then convert faces non-real to real. So I will say this is non-real, again convert it to real, so it is converted into real face. Then summary, so you can select a particular face and say summary. The summary will be given in transcript window. What is the name of the face, what is the meshing scheme applied, what is the interval size, interval count, is it meshed, how many total edges are there, name of the edges. And as there is no volume, so it has not shown the volume, and it will also give you the area of it, area of particular face. Then check is nothing but it will check the geometry for topology as well as geometry. So it has to give this kind of message, 0 out of 1 faces is failing. Then query is nothing but it will give you what is the particular label of the face, and total is nothing but it will give you the information of total number of entities, geometrical entities as well as mesh entities. So these are other operations, and this is the last operation that you have. You can delete the faces, selected faces, with or without lower topology, so that also you can do. So these are all the operations available in Gambit on faces. So first operation is create face by different operations, then create the primitive faces, rectangular, circular, ellipse, do a boolean operation, unite, subtract and intersect, then connect and disconnect operation, change color and modify the label, the move copy operations on particular faces, align operations, then split face, merge face, collapse face and simplify face operations, then convert, smooth and heal operation and convert face operation, and some summarize, check, query and total operation, and then delete operation. So these are the operations in Gambit which can be done on faces. In next lecture we are going to have a look at the volume operations available in Gambit. Thank you.